To go to the diseases, then, as I say, insects are affected quite often by fungal diseases. This is an aphid colony affected by, the term is entomopathogenic, so insect-killing pathogenic fungus. And if that fungus takes off, it can sort of wipe out the whole infestation, and that does sometimes happen in the middle of the summer. And big outbreaks are favoured by having a dense infestation of aphids, so the fungus can move between them, and also high humidity, so rainfall. And the fungus is there in the environment all the time. It just needs the right conditions and the host to take off. Next slide, please. And then insects also can be attacked by, say, various viral and bacterial diseases. And in some way or another, all three types of disease have been developed into biological control agents that you can buy and can be applied usually as a spray. And there's obviously scope for more of that. Next slide, please. So just to say a tiny bit about climate change. So there are so basically, always been interested, because I've been interested in insect development and temperature. Climate change has been something to think about, and DEFRA, quite a long time now actually, asked us to do some studies, if you like, theoretical studies about the potential impact of climate change on pests and diseases. And there are various approaches, and one of them is to use the mathematical models that we use to forecast pest attacks. So they're basically mathematical relationships between the rate of development and usually temperature. You can use those in combination with what we call synthetic weather data. So weather data that for example, the UK Climate Impacts Programme have produced to predict the impact of climate change. So you can run your models using that synthetic weather data for different time periods, so say 2020, 2050, 2080, or whatever. Next slide, please. So we've done that for a number of species. This is the peach potato aphid. You don't need to worry about the detail, but basically in the case of the peach potato aphid, because it does quite well at higher temperatures anyway, you'll just get more, what it's saying is you'll just get more generations. So it'll go through its life cycle more times in the summer, which obviously has consequences for crops and for management. Next slide, please. In terms of the cutworm that I was saying, the young caterpillars, the young larvae are susceptible to rainfall, then the scenarios, I think, basically say it's going to get dry on average. So this just shows a sort of relative estimate of what proportion will survive in the different time slices, so 2020s, 2050s, 2080s. So basically cutworms are likely to get worse as a problem. And then back to the old diamondback moth again. So basically at the moment I think our big problems come from the migrations, but there is at least one grower in southwest England who grows swede under mesh netting. Some of you may know them, and they have the mesh netting is to keep out cabbage root fly, but what happens is that the diamondback moths obviously lay their eggs on the mesh netting, they get through the netting, and then you get these really nice infestations under the netting. And so he has problems, and he has said for the last couple of years that he reckons they overwinter quite well. So a couple of us went to his farm in January 2018 and spent some time in his swede crops, and we found larvae there. So obviously they haven't completed the whole winter, but I think there is the potential for some to survive the winter in mild winters in warm locations. I still think at the moment that the migrations will be more significant, but that could be a consequence of climate change. And obviously the other one will be that they will be able to complete more generations in a year. So again, they'll become more problematic. Next slide, please. So the talk of climate change brings me to John Beddington and the perfect storm scenario with climate change at the centre, and then our increasing demands for food, for energy, for water, all of which are closely linked together and impacting on, if you like, climate change, and then the impact of all of that on biodiversity, so other species on Earth, which also we need particularly for food production. Next slide, please. And I guess, yeah, you're all aware, I'm sure you're all aware, that, you know, biodiversity is declining at a great rate, and there have been, you know, a number of reports and continue to be reports. And for example, in the last year, there have been a number of reports about insect diversity and the decline in the UK and in other European countries as well. Next slide, please. And then the latest report is the State of Nature report that came out, I don't know, in the last sort of week or so, which I think was produced by a consortium including National Trust and RSPB, and the news is not good. So yeah, you don't need me to tell you that we need to do something about our biodiversity in the UK and globally as well. Next slide, please. So in terms of factors contributing to biodiversity loss in the UK, then simplistically it's loss of habitat. Some of that is obviously due to construction. A good proportion of it is due to agriculture. And I mean, just need to look there and, you know, see how few trees there are in that landscape and how little diversity there is. And obviously also due to agricultural practices, which obviously is pesticides, but also is some of the other things that we do as well. Sorry? I can't hear. Right, the data points are the application of all pesticides to cereals. It comes from a pesticide usage survey report. So basically the blue lines are the treated area, which has gone up, and I think the red is the sort of amounts which have sort of stayed steady. Yeah, sorry, that was just a sort of illustration. Right, next slide, please. So again, you're probably all aware that organic farming does make a more positive contribution to maintaining biodiversity. There have been a number of studies. This is one of them. So basically saying that organic farming increased species richness by about 30%, and the result was robust over the last 30 years of published studies. So this is by them looking at a whole range of published studies. And organic farming had a greater effect on biodiversity as the percentage of the landscape consisting of arable fields increased. So it has more impact on biodiversity relatively, I guess, in intensively farmed regions. But the size of the effect actually depends on, you know, which species you're looking at, where you are, what crop, etc. So there is definitely a contribution there. Next slide, please. So I guess across all production systems, then the ambition must be proper IPM, which basically is about using all the tools that are available to you and using insecticides, for example, as a last resort. Next slide, please. And there is some pretty serious thinking going on about this for conventional agriculture at the moment, and particularly in continental Europe. And there's a new initiative, there's a new initiative which is it started off by France and Germany, which is towards chemical pesticide-free agriculture. Next slide, please. And there are a number of ways that you can, people describe IPM, they talk about the toolbox, or often they have this pyramid with cultural methods at the bottom, biological in the middle, and then you only come in with chemical if you need to at the end. So next slide, please. So what might pest control look like in the future? Next slide, please. So first of all, I think, crop rotation and crop separation, isolation are going to continue to be very important. And sometimes that's harder for organic growers than for conventional growers who often rent land and can sort of move around. And this is some work we did on carrot fly, which basically shows that the further away you grow your carrots from an overwintering site, the less damage you'll have. Next slide, please. Another tool is host plant resistance. It can be a very effective tool. Two sort of current examples. One is lettuce varieties resistant to the current lettuce aphid, Nasonovia. A single dominant gene, so full resistance, very effective, bred into a whole range of varieties, and now it's broken down because the aphids have actually managed to overcome it, so it sort of ceased to be effective. The other example is carrot resistant to carrot fly. That seems to be due to a whole range of genes, so less susceptible to being broken down, but harder to develop full resistance. And there's at least one seed company working on this. And then obviously there's the GM approach, where you can actually put the BT gene, the Bacillus thuringiensis gene, into crops. Next slide, please. Then there are a whole range of approaches using physical barriers, so net covers used quite widely. We've done some work on fences round fields, about 2 meters high, with an overhang that certain pests, they at least stop a good proportion getting into the crop. And obviously greenhouses, polytunnels are physical barriers as well. Next slide, please. And this was, I hosted an IPM conference in Stratford last week, and this was some photos that a colleague showed me from an organic farm in Germany. So you've got these tiny little lettuces in there, surrounded by whatever it is, a hay mulch. So I guess you'd call that a physical barrier as well. Next slide, please. Then you might try and sort of trap out your insects. And again, this came from the conference last week. This is a colleague working on wireworms in Canada, pest of potatoes, and basically what the wireworms spend the winter in the sort of margin. And so next slide, please. Basically what they're doing is putting out a load of traps to capture, I think, particularly the male wireworms before they mate with the females and get into the crop. Next slide, please. And that's, they apparently catch huge numbers of them, and it is pretty effective, but you have to use a large number of traps. Next slide, please. Another approach is to try and modify insect behaviour. So I'm sure you're all aware that some insects, female insects, release a chemical, a pheromone, to attract the males, and the principle behind this mating disruption approach, which is used for codling moth, and I think is available in the UK, is to just flood the area with that pheromone, with dispensers releasing it, so that the males can no longer find the females. Next slide, please. Then we go on to pesticides, and obviously there are some pesticides that can be used in organic production. And just to flag up, next slide, please, that there is quite a large AHDB project called Scepter Plus, where we are looking for both pesticides and biopesticides to solve pest, disease and weed problems in horticulture. So some of that may be useful to you in the future. Next slide, please. Then we go on to biological control. And that has, if you like, different terminology. So there's classical biological control, which is usually when people are wanting to manage an invasive pest, so a new pest to a country, and they will bring in one of the natural enemies to try and control it. And there have been some spectacular successes, but also a few disasters. And one disaster, which I think was an accident, is obviously the harlequin ladybird, which was introduced into greenhouses, I think in continental Europe, escaped from the greenhouses and then made its way to the UK and is now doing awful things to our native ladybirds. Next slide, please. The other approach, which is one that's probably used most commonly, is what they call augmentative biological control, which means that you release natural enemies, or you might use a biological control agent containing a virus or a fungus, and you release it once or several times. There are a large number of products now available across the world, not all available in the UK, that can be used, and as you all know, they're particularly effective in greenhouses, work really well. Not so easy to use in the field. Next slide, please. And one example I'm aware of is a large lettuce grower who releases parasitoids in their organic crops, but I've no evidence to show that they're actually effective. It's a big open space and they can just, clear off. Next slide, please. So what I wanted to finish off with is a bit about diversity, because I think that's the way forward.